Imagine, the second most populated continent in the world, full of potential and creativity, with no access to effective education. Imagine you were born in a world of impossibilities, with a great passion, and no one there to guide you. How would you prosper in this world? Africa to Silicon Valley. A2SV is building a digital bridge between Africa and the developed world. We are an academy that focuses on algorithms, data structures, problem solving, communication skills, and personal development.
In Turkey, I attended my first programming class when I was 13. By the end of high school, I gained enough knowledge to be hired by top tech companies. After college, I worked for Palantir and Google, delivering scalable products used around the world. Quality education positioned me for success, and I strongly believe it is our mission to give this knowledge back any way we can. We started with Ethiopia because we can make the largest impact in underdeveloped areas. Students collaborate with industry experts and receive the education they deserve. Most importantly, we provide the opportunity to impact their own communities.
After you graduate from college, you realize there's a massive gap between what you learned and how products are delivered in the real world. We think it's important to start very early with the students and have them build real products that their communities are actually using. Within just 3 months of a boot camp, we've been able to see these students grow, and we've been able to successfully place them with Silicon Valley companies. They're smart, they're hardworking, they're driven, and most importantly, they're hungry for success.
The world is yet to see the potential of the young generation in Africa.
A2SV has helped me grow in ways I didn't expect. The experiences and friendships I've made make me feel like we're a big family. I've always wanted to work with talented professionals on influential projects. And now here we are, working on a COVID-19 symptom tracking system for Ethiopia with experts from Silicon Valley.
Our goal is to optimize the circumstances for humankind to shine the real potential of the world.
I've always wanted to make noticeable changes and solve real problems in my country. I want to pass on what I've learned to the future generations, and I'm excited to build towards the future of Ethiopia and Africa.
Engineering is problem solving, and we understand great products require more than a block of code. That's why we want our students to experience real-world problems while delivering actual solutions to consumers. By matching these methods with talented students, 27% of our group passed Google internship interviews. Compared to Google's average acceptance rate, these students prove that talent is everywhere.
But the opportunity is not. That's why we're building a digital bridge between hidden talent and opportunity. What we've done so far is just the beginning. See the potential. Join the dream. Africa to Silicon Valley.
So in today's game, we have Mahlet here, who is going to be the first contestant or the first player of this A2SV last semi-final. And next we'll have Beimnet. I hope you know him well. He will also join us later to do the same question that Mahlet will do this time. So thank you, Mahlet, for joining. I think we can start. People are joining. We have now more than around 7 people. Could you please start by introducing yourself?
Okay. Hi, my name is Mahlet, and I'm a fifth-year software engineering student in AIT. And I've been with A2SV for 2 years now. Yeah.
That's nice. What do you expect from this game?
I hope it will be fun.
Okay. We can get started. I'm going to share you a link to a LeetCode playground. You have to sign in with your account, and it will be a live coding session. And I'll explain the answer once you have access to the playground. I have put the link in the message, in-call message of the call, so please go ahead and make sure you can access this playground?
Yes, I can access it.
Okay, nice. So you'll have 30 to 35 minutes to solve the problem. So basically the question is, you're given an array of numbers in an integer k, and you have to write an algorithm that returns the length of the length of a longest subarray with sum less than or equal to k.
Okay.
We have here at line 8 with the function definition that you are supposed to implement. It receives an array of numbers and an integer k, and it should return the length of the longest subarray with sum less than or equal to k.
Okay. So I'm given with a list of numbers and I target sum k. And should I return the lengths?
Yeah.
And if I don't find any subarray that equals the target, I should return 0 in that.
Yes, yes.
Okay. So
Are you typing, by the way, in the playground?
No.
Maybe I should be patient.
Yes.
Oh.
Can you see it now? So I'm writing it now. Can you see it?
Maybe I think there is some delay. I can't. Can you share screen so
Okay.
that it's easier for people?
Okay. Can you see it now?
Yes, incredible. Thank you.
Okay. Okay. So what I'm currently thinking is having storing the prefix sum of the given array, starting from the first one and every subarray, and when I got to some position, I'll try to find if I can find there is some noise behind. Okay. So at a given position, I'll try to see if I can find another sum whose distance from the current sum equals k from the previously calculated prefix sums, and if I find that sum, I would assume that the subarray between those two elements will be k. But to find the longest one, I would so the earlier one would give me the longest one. So I would keep the earlier one for as a prefix sum. So for this one, for example, at 0, I have a prefix sum of 1 at 0 and 3 at 1 and 1 at I have 1 at 2, right? But since I'm trying to see the longest one, there's no point of keeping this one, because whatever I got from the previous earlier one would be the longest one, so I won't keep this one. And okay, Let me also keep the value of prefix sum. So currently it will be 1. Then I'll add 3 on top of that, and it will be 4. So I find 4 at 3, and like I'll keep doing this, and like on each iteration I'll try to see the like if I can find a array here. So okay, let me
What's
finish
for
this.
4:3? I'm confused.
So like 4 is the prefix sum that I have at 3, like at index 3. I would have the prefix sum as 4, and like yeah, this will be how I would be constructing the prefix sum, but like on each
But
iteration, for example.
at index 3, the sum would be 4, right? Instead of it would
Yeah.
be 5, right? The sum. Yeah.
Okay. Yeah, it will be 5. Yes. So this one also it was 2 here. Yes. So in doing this, like I'll try to construct my prefix like this, and on each iteration, I would also try to find the subarray whose sum becomes k. So like on the first one, like my current sum was 1, and I'll be looking for 1 minus 3, which is minus 2, I guess. So minus 2 is not in my prefix sum, so I wouldn't have a sabari here. So like for the second one, like my prefix sum was 3, and so like I would initialize my prefix sum with like 0 sum at -1 index. Then so I'll find 0 at this point, and so the numbers like the sabari that I could find at index, while at index 1 is I think 1 minus 1, which will become 1 plus 1, and yeah, the length of the sabari will be 2, and I'll consider this one as the maximum current, the longest sabari, and I'll like continue doing that, and my prefix sum would become 2, and I will look for like -1, so I wouldn't find any, so I would just add okay, 1 is like 2 with 1 here, so I'll keep doing that, and with 5 I'll find, so with 5 I'll find a prefix sum whose value whose previous sum becomes the difference, and 2 was found in at index 1. I think I at index 2, right? Yeah. So I'll find 2 at index 2, and like I would have my prefix sum as 5 at index 4. So like 4 minus 2, I guess will become 2. But okay, let me see. So So yeah, it was, I guess, okay. Like 4 minus 3, right? Like 3 minus 2. And yeah, it will be 1. Like this is the only sabari that contains 3. Then with 2, it becomes 7, like at index 4. And so the complement of 7 will be 3. And 3 was found in 1. So 4 minus 3 would become like 4 minus 1 would become 3. And yeah, the longest sabari was 2. So I would update it to 3. And after that, like my like prefix sum will become 6 at index 5. And 6's complement is 3. Okay, 7's complement was 4, right?
But does it have to be exact? I mean, it could be SM at most K, not necessarily K, because it asks for less than or equal to K, right?
It says k is equals to 3. Okay. Is
Yeah,
it like,
so the sum could be at most K, but not more than K.
okay. So
Was I not clear about that, or?
I think I assumed it was like equals k, the same equals k. So then yeah, that would be a different question, right?
Perhaps.
Yes. Okay. So let me think about it for a minute.
Sure.
Okay. Okay. So what's the 4 elements in this array?
What?
Like what are the longest sabari for this one?
Oh, it would be 4. Right? It returns 4 because it would be -1, 3, 2. The last 4 elements would sum not greater than 3. So
Okay. Okay, so like what I'm thinking right now is like try to still complete the prefix sum and so I would start from like I would have like 2 pointers pointing from the start of the array, and like the first one like will point the prefix sum, the previous prefix sum, and like the and one would have like the first one would point to 0. So let me call it pointer 1, and the faster pointer will be pointing to the current running prefix sum, and it will be like 1 at first, and it will be pointing to 0. Like the current element in the prefix sum, and my prefix sum would like hold the 1 first, and like 1 is less than or equals to k, so we have a valid sub array here, like between these 2 pointers. And I will add it as my maximum sub array length, and my prefix sum will be incrementing like by the second element, and my the second pointer will be pointing to the next element, and once I do that, like I'll see that if the current prefix sum holds, which is like less than or equals to 3, it holds. So I have like 2 elements, maximum 2 elements in my sub array, and I need to accommodate the previous. I can. Okay.
By the way, can you add /live to the URL and everybody will be able to access what you're typing? Just add /live to the URL.
/live,
small letter live. Yeah.
This one, like in the URL.
Just /live. No. Add /live, not delete it, but.
Okay.
I'm gonna send you the link.
Okay. I don't think this works.
No?
Okay.
Okay, that's okay. Just share it then.
Okay.
Yeah. Nice.
Okay. Then, okay. I think it's gone now. Yeah. What was the example? Okay.
Can you see it?
No, not yet.
Okay.
Can't see.
You have it on the chat?
Okay. Okay. So yes. So I'll keep the prefix sum in an array. So I would have 1 first, then 3, then 1 again. Not 1, 2, then 5, I guess, then 7, and 6. Here are the prefix sums, and
yes.
So like 1 pointer will be pointing here, and the other. Okay. Yeah. Okay, I can add just okay. So like they will start by pointing at the same element. Then I'll try to see if my prefix sum like encompasses and like the maximum length will be 0 first. Will be 0 first, and yeah, I'll try to move my faster pointer to the right for on every iteration, and like while pointing here, I like my zero here. Okay. So like still it's in like 1 minus 0 is a value salary. So like my max length will be 1, and I'll move it here. 3 minus 0 is also valid, and my max becomes 2, and I'll move it here, and so 2 minus 0 is in my like valid state.
Okay.
So I'll add my max, update my max, and
Okay.
I'll move my faster pointer here, and 5 minus 0 is not valid, so I'll try to move this one, and like 5 minus 4 is not valid either, so I'll try to move this one, and this one is valid, but it's max, my current window is not greater than the max, so I'll move this one here, and 7 minus 3 is 4, so it's not valid, so I'll move this one here, and I'll move this one here, and 6 minus
I mean 7 minus 2 is not valid, right?
7 minus 2, yes.
So which one do you move?
Oh, like if
The
it's
left.
so yeah, if it is invalid, I would move this one, trying to okay. So either I have to move this one or this one, but if it is if I move this one, I lose like the maximum one.
Exactly.
So so okay. Okay, what else can I do? So what other thing I can do is like keeping track of the prefix sum with their index and sorting the prefix sum. So like if I have
But if you sort the prefix sum, how would a subarray? How do you maintain that the numbers that are in those two ends of your pointers are contiguous?
so like if I have a prefix, so like if I have the prefix sum with their index, like I'll keep the index, not only the prefix sum. So
Okay.
like if 0 was at -1, and like if I have one at index 0, and yeah, I'll keep doing this, and I think 1 and 2 was found in 2. And 5 was found in 3, at index 3. And 7 was found at index 4. And 6 was found at index 5. And yeah, like after completing this, yeah, I would sort them based on the prefix sum. And yeah, this one comes after this one. Okay, so after doing this, I'll try to find to find the extreme ones first, and like if I have another pointer here, so 7 minus 0 is not a valid one, and the range is greater than k, so I have to move my right pointer back, and 6 6 0 is also is not valid, so okay, I still have to move this one, but okay. Oh yeah, I think so like I need to move the, since like 7 minus like 7 is greater than k, I need to move the right pointer here, and like it will be pointing to 1, and yeah, 7 minus 1 is also not valid, so it will be 6, so I need to move this one, and yeah, 7 minus 2 is also not valid, so I remove this one, and 7 minus 3 is not valid also, so I remove this one. This will be the valid one, but like it's not okay. If it's the case,
Maybe
yes.
can you start with maybe a brute force approach?
Yeah, for the brute force one, like I would check every combination after this. So for one, I'll try to find the maximum, like the maximum. So like for 0, for example, I'll try to see if I can find the maximum from all iteration, like from all combination, and like I would find I think right here, like 2 minus 1, and this will be 3. And for every combination, I'll try every combination for this one, and also like for every prefix sum, and that will be of n square. And
Okay, and space.
space wise, I would also use extra array for like for accommodating the prefix and their index, and it will be of n.
Okay. I think that would work. Since we are in the last 10 minutes of the interview, maybe you can start implementing that, and you can see if you can do any optimizations to that.
Okay. All right. Okay. So I'll start by having the prefix array. Okay. So like I would iterate over the given array and keep the running sum, and I would add the given running sum with the index to my prefix array, and I'd sort the prefix array. Based on the running sum, and after sorting that, I'll try every combination. So max like longest sub array will be a what first, and I'll iterate so for sum and index. So I iterate over the given prefix array in a nested loop, and so I would have two sums, like sum 1 and sum 2, and try to see if their difference is less than or equals to k. So, it means there is a sub array between them. Like it is a valid sub array, so I would update my longest variable by maximum of the previous. Or the difference between so yeah, the next we will get on I. So yeah, it will be the longest one will be either the previous one or the difference between the two indices, and I'd return longest at the end. Yeah, the brute force solution would be this one, and yeah, it will be of n squared, and since I have another array, it will be of n. The space will be of n.
Okay, can we test it?
Okay. Yeah, okay.
Okay.
So,
Thank you very much. I have a couple of other tests at the bottom. if you don't have any edits that you want to make, it would be like a submission. Do you want to continue?
Okay. Let me see if I can. Okay. Mm, So if I only have one element, okay, I think it should be. Um. So they can be equal because like yeah, like for one for only one I wouldn't. Okay, I'm not checking. Yes, for this one it works. Okay. Yes, I think um
Okay.
yes.
Shall I proceed with the submission?
Yes.
Okay, thank you. Yeah, that succeeded. There are 26 test cases and all of them has passed. It took around 700 runtime of 718 milliseconds. Thank you very much, Mahlet. Thank you for joining us and doing this ACL semi-final, last ACL semi-final with us. Thank you very much.
So thank
And
you.
you'll have your feedback after the second game. Um, okay, I think we can proceed to the second game. Mahi solved the question. Even if it was suboptimal solution, she managed to come up with a working solution. And we'll see how Beimnet will approach this problem, and we'll decide who will. Maybe you guys, I might need some feedback from you guys or some inputs to decide who will pass based on the optimality of their solution. Thank you very much. See you in the second link. Hello everyone. I think we have enough people to start the second game. We also have one of our contestants, Beimnet, joined. Welcome, Beimnet. Can we start by introduction? Can you introduce yourself to me and also the attendants?
Thank you, Murs. My name is Beimnet. I'm a recent graduate from Addis Ababa University in software engineering. I'm currently working on education at A2SV, and I'm really happy to be here.
That's nice, Benny. What do you expect from this game?
I expect a challenge.
I think you will. Okay, so we're going to start the interview or the challenge now. You'll have around 30 to 35 minutes to solve the problem, and it will be on LeetCode Playground. I'm going to share you a link to the playground, and you'll be completing a function definition partially written by me. So I have shared the link in the in-call messages in the Google Meet call.
Okay, thank you. Yeah, I'm currently in the playground.
Awesome. So we can start, right?
Yeah.
So the problem is you are given an array of integers and a number k, and you should write an algorithm that returns the length of a longest subarray with sum less than or equal to k.
Okay, so given an array and k, we should return the longest subarray. Sum
With
is
sum not exceeding k.
Okay, so in this case, the answer is 4. Like I'm trying to go over the example right now. So case 3. If we 1 and 2 is 3, so if it's k, it should be fine, right?
It's fine.
Okay, so -1 here. The sum until this point is 2, and yeah, but here it exceeds k, I think. So far we have found a length of 3. Yeah, but if we okay, so I was saying I was considering to consider this, but this also exceeds k, right? So in this case, which one? Yeah, which one would be the answer?
The answer would be this last 4 elements
yeah.
not exceed k.
I see. Okay. Yeah, I think the question is clear. So one question I have, so as I have seen in the example, we are also including negative numbers, right? 0 and negative numbers.
Yes.
Okay.
Yes.
Okay. So far I don't have any other question. But if there comes a clarifying question when I'm working on the solution, I will ask. So can you give me 2 minutes to come up with a starting point?
Take your time.
Okay. Okay. Yeah. The brute force would be first to start with every starting index and to go as much as possible. Like even if it exceeds at some points, even if it exceeds k, we should keep moving to check if there are negative numbers from that point on, so that it falls by sum up elements in the subarray starting at index I and at some index I, and like to maximize the length. But if we do that, our time complexity would be quadratic. So we want to improve on that, basically.
Is it purely quadratic, or I mean, could you show me like a walkthrough how that is going to be n squared?
Yeah, it would be n squared over 2. Like, okay, so we start at index. For example, if you see, we start at this pointer and we try to go until we until the end, basically. Every time we try to get
Yeah.
until the end. So now the second time, the length would decrease by 1, and the third time it will decrease by 1. So it will be, it won't be purely n square, but asymptotically it will be n square.
I mean, you have for each pair of indices, you are checking if the sum from the
Those
left
two?
index to the right index is less than or equal to k, right? How much
The
would it take to
sum.
complete the sum?
Yeah, for each index we have to sum them, but yeah, in order to make it n square, we have to keep a different array, or just change this, change the input array to a prefix sum, so that at each index, that index will have the sum of values starting from 0 to that point on. So, for example, when we change this array into its prefix sum, it would be something like this: 7 and 7 and 6. So in this case, I can start from each pair, and I can get the sum between them in constant time. That'll be the case.
Got it.
So, yeah, because yeah, this 7 is the sum. For example, if you pick between this point and this one, this is the total sum until this point, and when and this 3 takes in, give me an answer from 0 to this point.
Share your screen, please.
Oh, okay. Okay. Is it visible now?
Yes.
Okay, thank you, Mickey. So, yeah, this give me a sum until this point. So one prior it give me a sum until. So in order to get the sum between these two, I will just subtract 7 from 1, so that 6 will be the sum in between. Yeah. So in this case, it would be. Yeah. I hope so. I hope so. Yeah. So let's say we have this prefix sum, and okay. Can you give me a minute to improve on this?
Sure.
So the first solution was not actually n square. So now it is n square, because the first one would have gone to n cube.
Yes, exactly.
Yeah. Okay. Currently, I haven't come up with any other solution, but let me try to discuss the problems. So the problem is with negative numbers. If all are positive, I know I'm for sure. I know for sure that this prefix sum array would increase always, because we won't find anything like this from 3. We won't go down to 2. And if that would have been the case, my answer would be, so for every pair, for every pair, I could have find, not for every pair, but at each index, I will find like the longest,
How far you can go.
how far I can go easily. Yeah.
Can you pre-process it to maybe to make it easier for you to pre-process to allow you to go as far as you go?
I see. Okay. So maybe I should do something about the negative numbers. Okay. Give me 2 minutes to think about it.
Sure.
Okay. So just wanted to go over how I would do it without negatives, and maybe try to handle the complexity of the complexity that negative numbers cause. So if it were, so I think it would be easier for me to start from there. So if this was the array, and k is 3, the sum at each point would be like the previous prefix sum array would be something like this: 8, 11, and 15. So at each point, I don't want like if I consider each point the end of a subarray, and in order to, so at each point I can try to find where if the current subarray I'm considering is ending at the current point, where should I should answer? I will answer the question that's where it starts. For example, if this was my end, and k is 3, I don't want the sum. I don't want the subarray sum to exceed 3. So in that case, I'll try to find something closer to 5 in my previous before 8. Before this point on, I will find I'll find 5 in this part of the subarray. I'll try to find 5, or closer to 5, closer to 5. 5, or like not closer, but at most it should be 5. So I'll try to find upper bound for 5. Does that make sense?
Yeah, I get it.
Yeah, okay, so if that is the case, for each point, what I will do is I can do binary search in this part of the array, to find the upper bound for the current subarray sum, 8 minus k. 8 minus k would be 5. So at each point, I'll do binary search to find upper bound 5 for 5 and maximize like the links I have. So this is clear, right?
Yes.
So what would happen? What is the problem when there is negative numbers? So one thing is I cannot do binary search because the prefix sum wouldn't be sorted. It wouldn't be sorted if there are negative numbers in it. Okay, so I'm trying to find a workaround for that. Okay, so here at this point, we've gone from 3 to 2. And so what if I don't consider negative numbers, and like what would be the benefit if I don't consider negative numbers?
If you don't consider negative numbers,
Yeah.
and if the sum exceeds k, you're gonna ignore it. But if you include some negative number, the sum is gonna be lower, so it will be longer and within the limit.
Yeah.
So if you are at certain point and you know the next number is negative, or if it's not increasing, do you think it's necessary to stop there as the end of your portion of subarray?
Sorry?
You're at a certain point and you know next to you there is a prefix sum that's lower than you. So do you have to consider that number as the ending point, or is there any other better solution?
Yeah, nice. So yeah. So this prefix sum, like that's a very good point. This prefix sum. So let's say k is, let's say this point is, what was it? Let's say this is 3, and the prefix sum would be, sorry. Let's say k is 2 at this point. K is 2, and I'm trying to go as much as possible, and I'm trying to find my window here. And at each point, when I try to reach to 3, I see that I'm beyond k, but I shouldn't stop that because of, if there is a prefix sum after me that is below me, it means there are some negative numbers in between that will make this subarray, the total sum of this subarray not more than k. So at each point here, like I will try to go as much as possible, and I'll what I will do is I'll also have maybe, let's say, the minimum point of the minimum prefix sum after me for each point, for example, here. So I will try to go from right to left, and the minimum prefix sum at this point is 6, and at this point would be 6 again. At this point it would be 5. At this point it would be 2, and 2. I think. 1. Is it 1? At each point, I want to know the minimum prefix sum after me. So let's not consider ourselves in this. So if that is the case, we can start with 6, and this should be 6. This should also be 6 after it. So this should be 5. The reason I'm doing this is not to consider the current moment. So this should be 2 and 2. Okay, so if this is the case, I will have 2 pointers. They both start at the zeros initially, and I'll check if the second pointer is greater than k. Greater than k. If that is the case, if that is the case, okay. If that is the case, I can move on until I find a sum that is greater than k. So here it does be greater than k, but I know there is a sum after this that will make the Sawari sum below k, below k. So
yes,
in that case, I think I should I can directly go to that point, right?
Yeah, I think so.
Yeah. Okay. So in my array, maybe I can store the indices as well, the point in the indices as well. So I can directly go to this point, and again, like when I try to go to the next point. So okay. So I think I want to have one more minute to think about the details.
Sure. Okay.
Okay, so like my current idea is I'll have separate array, as I said, that keeps track of the minimum after me, like the minimum point after me. So, so let me have the indices as well. This will be 2, 2. The minimum sum, like I only need the indices like to represent them. Let's have them both here. But in implementation, I can remove the number. So for 5, it will be 4, 1, 2, 1, 0, 1, 2. Yeah. Okay. Be 5. So this would give me the minimum, like the minimum after each point. So the minimum sum I have after each point. So I'll do the prefix sum for the given array. This would be my prefix sum.
Okay.
And what I'll do is I'll use a 2-pointer approach. I'll start both of my pointers at the zeros index. So at each point, I'll try to calculate my current Sawari sum. My current Sawari sum at each point would be. So in order to make my calculation easier, I'll add a 0 to my prefix sum array and start from the first index. So not the first. I will make the first pointer at the zeros and this here. So now what I will do is I will calculate the current Sawari sum. The current Sawari sum would be my second pointer minus my first pointer. So at this point, I will have a Sawari sum of 1, which is less than k. So from here on, what I will do is I will just jump to the next minimum point from this array. So the index of that point. So that would be at index 2. So my second pointer will go to this point. So now I'll try to calculate my current Sawari sum. So my current Sawari sum would be still it will change to 2, right?
Okay.
So 2 minus 0, it will change to 2. But still, we didn't exceed k, so we can make a jump. We can make a jump. So like we will also try to we'll also try to jump to the next point, which would be 3 at this point. 3, index 3. So now I'll calculate my current sum, which would be 5. Now it is exceeding k, but at this point I'll not try to at this point, what should I do at this point? Maybe okay, yeah. So at this point I should minimize my window, right?
Yeah. Don't you have to save the longest value that you have gotten so far?
So far? Yeah. I'll save that. Sorry. Yeah.
Okay.
I'll maximize my longest valid so far. So let's assume I'm doing that for now.
Okay.
So at this point, when my sum is exceeding k, I'll try to minimize. So in order again to minimize, I'll move my my current point by 1, my left point by 1. Just move my left point by 1. So it would be okay. So yeah. So now it is still not within the range. So I'll do again move my left by 1. Now it is in the range, right?
Okay.
5 minus 3 would be 2, so it's in the range now. After this, I'll try to jump to the next minimum point. The next minimum point, okay. I can also just go one. I can also move my right pointer by 1 every time until I have the indications that there is a possible next minimum point that will be that will make my current sum within range. Does that make sense?
Yes, it does. It's your choice. You can jump either directly to your next minimum or jump by 1.
Yeah. So in this case, the time complexity would be linear. It would be 2n. At most, we'll be touching each element by these 2 pointers, but we also have to iterate through the array to calculate this minimum array and this prefix sum array. So okay, I think this will work. Maybe I should test it with more example, but I'm considering like I'm running out of time as well.
So yeah, I think we can proceed to the implementation.
And yeah, let's do that. And in the meantime, we can, if we find bugs, we can correct them. Okay. Let's have the. Can I use the original? Can I manipulate the input nums into the prefix sum array I talked, or should I use an additional memory for that?
No, you can't modify them.
I cannot modify?
Yes.
Okay. So let's, in that case, let's just have an additional array. So I will build the prefix sum here. So in order to do that, I'll iterate over the numbers in nums, and my prefix would be my current. I'll add the accumulated sum and the current number into my prefix array. So this would be the accumulated sum would be at the end of the prefix. So I'll add num to it. So I think this would give me the prefix sum array, and okay. So yeah. Also, we have the minimum array, the next minimum array, next min, which would hold the index for each minimum. It should be initialized with the length of the length of nums, the nums array. So okay, so at each point. So at each point, I'll try to start from the end of the prefix array and try to calculate this next min index.
Okay.
Since maybe I should start with like nums of 0 for this, and I don't want to complicate the indexes for now. So yeah, this should still give me the prefix sum array.
Okay.
Yeah. And the next nums will be, I will start iterating from the end of the prefix. So it is the same length as the nums array. And what I will do is, and I should start from the 2 from the last element, because
the last doesn't have 1. Okay.
Yeah. So at this point, so here, the last element next min of the last should be should be itself, right? The next
Okay.
minimum of the last should be itself, right?
Okay, that makes sense.
Okay, so in that case, I should just say I should just store the length of carry -1 to this, and first here I will compare. I'll compare my at this point, for the second last element, let me copy here.